Good morning, friends. I hope you are safe in the COVID pandemic. So, this is Dr. Sunil Mahagaonkar, Faculty of Mechanical Engineering Department. And now, in the last sessions, whatever had, so we have completed the joints. And now, design of shaft is also I have taken. It's a very important portion of that one. So now, based on the design of shaft, so in this particular session, I'm going to elaborate what are the steps we have to take it while designing the shaft, or how the problems data are given and how we have to tackle it. So instead of going to the actual problem, so I will just take what are the datas, and with those data, how we can get the solution. Okay, so trying to understand the procedure is very important rather than implementing directly or attacking the problem. So anyhow, you have studied the different theories, that is theories of failure you have studied, and then you have studied what are the shaft is subjected to the combined shock and sub bending and twisting, and ASME code equations you have learned, right? So and then based on rigidity you have studied, but actually the shaft, it is there for deflection and the critical speed, so that is not for your curriculum. So hence I have not taken that one. So this is related with a shaft subjected to the torque and bending moment, and any rigidity thing if it is angle of twist, if it is given. So in that case, how we can get it? So that thing I told it, I explained in the last session. So anyhow, we will start with continuing with my presentation on problems on design of shaft. So at the end of the session, students are going to learn. So the identification of the problem. So whether the problem is based on solid or hollow shaft, whether we have to solve the problem with the ASME code equation or normal with the given stress values. You have to write down the given data properly, and while writing the given data, should make it in the units, given units. So it should be in millimeter. It is better take it in millimeters, because power is in watts. When you take generally the students will do the mistake while calculating the torque. So they will calculate the torque in Newton meter, and then by using what is the stress value, it is in Newton per mm square, if they use it. So then the answers you are going to get it in either in meter nor in millimeters. So that's why. So you have to check always the stress units properly. Assumptions of the data, if it is necessary that we have to assume a suitable data. So it is very essential in designing the proper data. We have to assume it, and what is asked. So that is also very important. So read the problems correctly and try to get what he has asked, and based on that your thinking will start, and you can the process of solution will start with identifying what he has asked in the problem. Adopting the right procedure, we have the whatever the procedure I am going to tell you, that procedure we have to adopt it. So and then finding the right solution. Okay. So general flow process for the solution. It is identification of the problem, as I described, writing a given data and identifying what is asked. Data analysis will be there. So it consists of two things. One is data other than the strength and factor of safety, and this is the data related to the strength and factor of safety. I made it separate because it's an we are having much more importance on this as well as this. So first we will go for this yield strength. If we has given the specific material, yield strength, ultimate strength, factor of safety, then this is the way we have to find out sigma allowable. For tensile, for ductile material, SYT upon factor of safety. This is based on normal stress theory. SUT upon factor of safety, ultimate for brittle materials. Okay, and allowable shear stress for 0.5 SYT upon factor of safety for using maximum shear stress theory. And if they told you to design with the maximum shear distortion energy theory, then we have to use this equation. Okay. So adapt the right procedure. While taking that one, we have to assume the data. If it is relevant data are there, that we have to assume it. And finally, we'll get the right solution. That is the end to get the solution for the problem. Design procedure for the shaft. So the first step is to find allowable stress. So to find allowable stress, it is the first step in the design. So here the allowable stress and tensile stress. Just now as I said it, the allowable sigma T or allowable shear stress, that is tau S, or sometimes a crushing stress if it is there, how we have to calculate. So as I said, if SYT factor of safety is given, SYT, and ultimate strength is given, so then I can use that SYT upon factor of safety for finding out sigma T. Okay, for ductile, generally shaft is made up of ductile material, so there is no need of going for a brittle material. But ASME, for example, if they given allowable shares ASME code equation, so then what do we do? So ASME code equation. So for that, there are two things available. One is commercial shafting, and the other one is when the shaft is given with certain material specification. So based upon that, we have to decide it. So what is the factor of how we can calculate the allowable stress? Say for commercial shafting, I will tell you, the allowable stress, shear stress, may be taken as 42 megapascal or 42 Newton per mm square for ductile materials. Okay, that is with keyway is there. And if it is without keyway, so then the allowable shear stress, you can take it equal to 46 or 45. Okay, so this is for without key. Okay, in the same fashion, that is what is the allowable shear stress for allowable shear stress value with the ASME code equation when the for the commercial shaft. Okay, this thing I already told you. So, but when it is specified, when that is specified, say for example, I had given a problem in that 45C8 is the material. Okay, 45C8 is the material. This is based on what tensile. That is tensile strength is 350 Newton per mm square. You will mention it in the problem, or they will mention in the problem. And the second one, they will also mention what is the ultimate strength, SYT and SUT. YT stands for its strength and UT stands for ultimate. Okay. They will give SYT and SYT. What we have to take is the allowable stress is equal to, it is 18% of SUT. 18%, that means 0.18 multiplied by ultimate strength, or 30% of SYT, that is 0.3 multiplied by SYT. So whichever is the less value, so that less value we have to take it, and that should be further, it should be multiplied with 0.75. We have to multiply with 0.75 for the shaft having the keyways. That means what? You are reducing the value of the strength by 25%. Okay. So whatever the less value, whichever is the less value, we have to take it. Say one thing I have got around 80 for considering SYT, and say if you are getting 90 for considering ultimate. So in that case, the lesser value is 80, then I will choose 80. And further, this should be reduced by 25%. That means I have to multiply it by 0.75, because normally the shaft is having the mating parts like gears or the pulleys, right? So the keyway is there, so that's why the keyway is there, so hence we have to reduce it by, that is why we have to multiply by 0.75. So this is all about, that is how we have to take it when to find the allowable stress. That is the first step. Okay, when the ASME is given. So suppose if he has not given ASME, then what he will give? That is yield strength, ultimate strength, like that, and factor of safety. So then we have to divide it. Okay, the second step. So second step, it is to find the torque. This is the first step. Second step is to find the torque. That means power he has given, P into 60 upon 2 pi n, where P is in watts. So multiply this one into 10 raised to 3, you must get it in Newton millimeter MT. Okay, because RP radius value it is in millimeter, so that's why it is better always take MT, it is in millimeter. This is whatever the MT here what I have written, it is in Newton meter, you will get it. So further this should be multiplied with 10 raised to 3, and then this is one way of getting MT. So there are 4 or 5 ways I had said it. So the other one, they may give power. If the power is given, you can find MT based on that. If suppose power is not given, then they will give T1, T2. That is what T1, T2. These are the tensions or maximum tension in the belt. They may say that the maximum tension in the belt is 2400, and the ratios of the belt tension T1 upon T2 they will give it. So in that case I can find what is T1 and what is T2, and if the radius of the pulley is given, then I can find MT, and this MT I can use it further in the design equation, which is d cube is equal to 16 by pi into tau s under root mb square plus mt square for finding out MT. So there I am using it. Are you getting it? So this is the how we are going to get MT, that is the torque based on power. When the power is given, when the tension and tight side tension is given T1 agar diye, and then T1 by T2 is also is given. So in that case I can take find out torque from that also. Okay, and now power is also equal to, suppose if he has not given these two things, so let us say he has given the tensions in the belt T1 and T2, dono diye. He has given T1 and T2, and the V, that is what is the speed, this speed also he has given, the belt speed. So in that case, by multiplying this one I can get the power. Once you know the power and if the RPM is known, I can get what is MT. Okay. So the third thing, if these three things are not given, that you should give what is the gear, that is the tangential load acting on the gear, and the radius of the gear. So using that also you can find out the power, that is a MT. It's not power here, it is torque, you can find out. Okay, the other one is I can find directly the torque based on if tau s value, if he has given the diameter. See, so many times the students, they in a problem they will give the diameter also and tau s value, but while solving the problem, they will not give this thing, power and tensions, they are not given, but the students will get confused. So sir, he has not given the torque. So it's not like that. So when the allowable shear stress is given and diameter is known to you, so you just multiply this one, that is pi by 16 into tau s into d cube. That is the maximum torque it can sustain. So that's how we can calculate the torque when the diameter of the shaft is given and then the allowable stress, right? So this is the second step in the designing. And now the third step, I will go in, this is the third step, tensions in the belt. That is vertical tension, and then the second one is horizontal tension. So normally the design problem, it is very simple. We are drawing it first, we are going for only vertical loads and vertical movement diagram, and then horizontal load and horizontal movement diagram. And then since these are the vectors, I can get the vector sum by taking the by using the right angle uh, formula. That is we can get the resultant of movement is equal to the sum of the base and opposite square. So by doing that I can get the other things. So that's why we have to go for the tensions first. The loads, we have to go for the loads. What are the different loads he has given, weight of the pulley, has he given or not, vertical tensions if it is given, whether it is acting in the downward or acting upward, that we have to see it. Okay, and at each point what are the points, so that we have to see it. Okay, so now in this, the tensions in the belt you can calculate by using these two equations. One is mt, as I said it, from this, any of one, and then if you know the radius of the pulley, you can find out the tensions, the ratios. If you know it, T1 and T2, I can get this is T1 by T1. So actually it is T1 upon T2. Okay, is equal to e raised to mu into theta. So using this value, I can get the third step. This is to find out what is total the load which is coming acting downward, right? And the weight of the pulley also we have to take it. Once you know the loads, that is vertical loads and the supporting members, so then I can we can draw it with it is just a simple strength of material equation, that is the application of strength of material we are using here to find out the reaction. Okay, so we have to find out the reaction in this with the vertical load diagram. We have to find out the reaction at the supporting points. Usually at the free end it will be zero. Sorry, the reaction will be there, but the movement will be zero. So now the fourth step is to draw the vertical load diagram and vertical movement diagram by finding the reaction. So find the reactions of the support by considering the vertical load due to the vertical belt drive and the pulley weight. So this is very important. Okay, vertical load diagram and vertical movement diagram. You have to find out the reaction by considering vertical load, and sometimes the students will forget the adding the weight of the pulley. So if the weight of the pulley is given, you take it, otherwise you don't take it. Okay, So then the fifth step is to draw the HLD, that is a horizontal load diagram and horizontal movement diagram. Okay, so that is to find the reactions here. So find the reactions of the support by considering horizontal load due to the horizontal belt drive and the pulley weight. If it is a pulley is there, belt drive is there, you have to take belt drive. If it is a gear is there, in that case we have to they will give what is the tangential component, and you will get one resultant load, so that angle is given. With that I can find out what is the vertical load and horizontal load. Okay, suppose in some other cases the problem, you may get certain inclined angle. If the belt tensions are not vertical, either it is not vertical nor horizontal, but it acts at an angle. So in that case, I had to resolve that force T1 plus T2 that is acting at this point. So the two component, one is vertical and the other one is the horizontal. So like that I had to resolve that component in the vertical and horizontal way. All right, this is the fifth step. And the sixth step is to draw the resultant movement diagram. Once you get what is the vertical load diagram, vertical movement diagram, horizontal movement diagram, in that case I can get the resultant movement diagram. Mr is equal to root of mv square plus mh square. So here we are taking at each point you try to get what is the mr at a, mr at b, mr at c, like this. Okay, mr at a is equal to mva square plus mha square. What is mva? It is a vertical movement at the point a, right? So yeah, horizontal, this mha is nothing but the horizontal movement at the point a. Like that we have to find out the reaction, because this moment is a vector quantity. Why? If one is acting in the horizontal and the other one is acting in the vertical, so the resultant of this will be the hypotenuse. So hypotenuse is nothing but the sum of the opposite square, that is a vertical component square, mv square, and the other one is the horizontal square. So if you do it, so that is the resultant, and out of that I had to find which resultant, mr at a is maximum, b is maximum, c is maximum, or d is maximum. So that is nothing but the bending moment, right? So we have to take that is the mb factor. So once you know mb and mt, you just put the value in the equation, because ultimately what is you are required for designing the shaft based on this is for shear stress, based on allowable stress, and this is based on principal stress. Both are principal stress equation only. This is based on tensile stress and this is based on shear stress. So we can use it here. MB is equal to, I have to take MR maximum. So in MR maximum, when I take that illustrative example for that one, so then you will come to know clearly about this one. So whatever I told you, so it is on with the action of mine or with the things of explanation. So I think you have understood little bit of that. So I will explore over these things in the next slide. Uh, so you just take a problem of a shaft. For a simple case, we will go for this. That is an overhang pulley. What are the given datas? Given datas, I can take power is equal to watts, kilowatts. RPM is it is given. Yield strength of the material is given. Factor of safety is given. Pulley diameter D is also given. Belt tension ratio T1 and T1 upon T2 it is given. Coefficient of friction, belt or the wrap angle theta in degrees. Actually, they will mention theta is a wrap angle, it is in degrees. They will give it, or else in the problem with the figure they will you will come to know. Illustration of the problem or the figure with all dimensions. Sometimes they will give the illustration of the problem. Okay, so then it becomes somewhat difficult. But if the figure problem is there, in that case, it becomes very easy. If the illustration is there, so then one should note down those. When you draw it, you try to compare 2 or 3 times whether you have drawn the figure correctly or with the given illustration or not, right? So the illustration, the figure should be right. If the figure, based on the figure, your solution will be there. Are you getting it? So that's why one should be very careful when we are drawing the figures. Is it clear to you? So now let us, as I said, it is an overhang pulley. Overhang pulley means this pulley is overhang from a bearing, right? So this distance they will give it. Let us say 300 millimeter from a bearing, right? And this pulley drive is a horizontal. Let us say the pulley drive is horizontal, and the tensions he has given T1 and T2, or else he has given power. With the power I can find tension ratio. He has given T1 upon T2. I can get the power from the power. I can get T1 and T2 like that. Okay, weight of the pulley. It is weight of the pulley is there, right? So now this first step, find the allowable tensile stress and shear stress. Okay, so sigma allowable tensile, brittle. Generally, they will not give this material is not there. So hence, allowable 0.5 SOIT upon factor of safety. This is with the distortion energy theory. This is the first step. In the second step is to find the moment due to torque. Mt is equal to P into 60 upon 2 pi n Newton meter. So it should be multiplied by 10 raised to 3 Newton mm. Okay. So in the third step, to find the tensions in the belt in order to find the total horizontal or vertical load. Okay. So we have to find out the tensions in the belt. Okay. So you just see here in this problem, T1 and T2, belt drive is horizontal. Okay, belt drive is horizontal. So what you will get is T1 minus T2. That is tension. T1 by T2 is the ratio. Yes, if it is given, it's okay. Otherwise, he should give mu and theta. What is mu? Coefficient of friction between the belt and pulley, and theta is the overlap angle. So what is the overlap angle here? The wrap angle of the belt on this pulley is 180 degrees. So the theta is 180 degrees. That 180 degree we should not put it here. You should put in radians. What is 180 degrees radians? Radians, it is a pi. So it is e raised to mu into pi. If it is 180 degree. If it is 120 or 60 degree, accordingly we have to calculate it in radians. Okay. If you do it, you can get around 2.25 or 2.5 like this. Okay. So usually these values are there. If it is not given, you assume the value as equal to 3 or 4. Okay. 3, 3.5, 3 or 2.5, 2. So anything between 2 to 3, 3.5. Okay. Usual values are 2 to 3.5. It can be calculated knowing coefficient of friction mu. It is generally, if you remember this one, it is better. Use mu. You can assume the value of mu. That will be always there. You can find out with the problems or with the given data. And then wrap angle, if you know it, and then you will get this answer, e raised to mu into theta. And once after finding out the solving the problem, th is equal to t1 plus t2, I can get it. Okay, horizontal component. So th is equal to, that is t1 plus t2. And then now the fourth step is to find the maximum bending moment. So that means here I have to go for this. So draw this figure, you draw it neatly, and then right figure you can use it for the writing the equations like this, and then the left side place for the drawing the figures. Okay, first we will go for the vertical load diagram. So this is a vertical load. What is the load? WP. It is a vertical load. It is acting at this point. Is there any other than this vertical load? No. Okay. So now vertical movement diagram I will draw it. So vertical movement, the reaction will be, this is a clockwise, this must be an anti-clockwise reaction. So here this is MVA is equal to WP into L. So like this, if I do it, this is the reaction, you will get it. And this is MVB, the horizontal load diagram. Horizontal load, you have to only consider horizontal loads. So what is the total load? TH, which is the horizontal load. We take at the point B. So that point B I had taken. And then once again, after taking this, again the length, you are knowing L is the length. If it is L is the length, so then I can draw what is that? Horizontal movement diagram. So MHA is equal to TH into L. You can get it the horizontal moment. So now the last one is the resultant moment diagram. So resultant moment diagram, I can get it by adding the sum of the squares of A and B. Okay, MR at A is nothing but MHA square plus MVA square. MRB is equal to 0 because these two components are 0. So like this I can find the maximum. So this is nothing but MB. MB is equal to maximum bending moment, which is nothing but the MR maximum. So this is the moment, MR resultant moment diagram. So in that MR you are going to get maximum. So that value you have to take. This can be obtained. This MB maximum, MR maximum can be obtained from the resultant moment diagram that I have shown here. Okay, so by taking that, we can find out, that is using this equation, tau maximum is equal to this equation 16 upon pi d cube into under root mb square plus mt square. If kb and kt factors are given, you can add it. kb mb square plus kt mt square. If it is not given, you omit it. So tau sigma maximum, it is sigma maximum is equal to 16 upon pi d cube into mb plus under root mb square plus mt square. So whichever is the diameter is more, so that value we have to take it for the design. Okay, so the next one we will go for the sum of the problem for the with the same thing in the next video.